Atulpriya Sharma, and he'll be speaking about accountability and identity in agent native Kubernetes.
Thank you so much for joining in. I know it's a bit after lunch, but it's before break as well, so I'll try to keep as simple as possible. So before I begin, a quick show of hands from all of you. How many of you all took at least one flight in the last 1 year? At least one flight. That's about 85-90% at least. So one thing all of us would have experienced by taking flights is, first, obviously the airport is too far. From Bangalore you have to travel to Hyderabad to reach the airport. It's that far. Second, obviously to enter the airport itself is a very big task. You know, whether you have a DigiYatra or not, you upload some stuff, you upload your boarding passes, you get your DigiYatra in. Once you get that in, you go and put your luggage for check-in. That's where again they check your Aadhaar card again, check your boarding pass again. Then you go through your security check where you are frisked manually by human, your bags are checked. And then if you are a foodie like me who wants to go to a lounge, you will have your bunch of credit cards and you will be like, ma'am, see whatever works. And then out of all of those, ma'am will keep trying stuff and then eventually something will work. And that will allow me access to the lounge. After that, I go to the boarding gate. Again, my Aadhaar card is checked, my boarding pass is checked, and then I'm allowed to sit on an aircraft. You imagine this entire journey. I did this journey about 20 hours before, and that's what, this is a LinkedIn post that I did yesterday. And if you look at this entire process, you see how many checkpoints and controls are in place for you to go and sit on an aircraft and travel. Whether it's a 30-minute flight or a 30-hour flight, the process remains the same. But when it comes to AI agents, why don't we have so many checkpoints before they do something? So that's exactly what I'm going to discuss today. Who authorized that agent within your systems? And we'll talk about how to build accountable AI as a platform service. I am Atulpriya Sharma, and I work as a senior developer advocate at Improving. We were known InfraCloud earlier. I have been the co-chair for KubeCon India that happened last year, which is the largest conference on the earth on cloud native and Kubernetes tech. I'm also CNCF ambassador, and I am the co-organizer for meetups in Hyderabad, as well as the lead for the global platform engineering community. So my areas of interest are usually platform engineering. You'll see me talking a lot about platform engineering. I dabble with a few tech and tools around it. And obviously things associated with it, DevOps, DevRel. GenAI is there because if it's not there, I wouldn't be here. That's why GenAI is there. So if you all want to know what all I do as part of my work, that's my LinkedIn page. We can connect there and we can discuss anything that you want to discuss. Outside of work, I'm a big time foodie and a travel blogger. Some of you might know, some of you would not know. I've been doing that for a couple of decades. I enjoy traveling. I love historic places. I love UNESCO World Heritage Sites, temples, architectures. I love food. So, CTRs, Vidyarthi Bhavan, NTRs, Brahmins. Give me records after the talk. I'll see if I can go to some place tomorrow morning or not. And I enjoy cooking a lot as well. So if you want to know what I do in my day-to-day life outside of work, that's my Instagram handle. You'll get to know what I'm eating, what I'm doing, things like that. And that's why, because I'm interested in travel, I started talking about travel. So to get my ginger ale at the airport, I know after putting that story on Instagram, a lot of people told me that, bhai, you could have just walked into a supermarket or ordered ginger ale on Blinkit. Why did you have to go to an airport lounge just to drink a ginger ale? But that's the story. So to get a ginger ale at the airport, you see how many things I had to cross through. First, DigiYatra check to get into the airport. Then security check that checked my bag and told me, boss, you have laptop, you have wires, you have power bank. They threw everything outside. Then my credit card check to allow me access into the lounge so that I could have my ginger ale. So every checkpoint at the airport knew exactly who I am. My DigiYatra account has my Aadhaar card link. Aadhaar card link is linked to PAN card. PAN card is linked to my bank account. Bank account is with income tax. So they exactly know who I am, who is trying to enter the airport. Every checkpoint also enforces what I am allowed to do. So the moment I cross the DigiYatra barrier and get into the airport, I have only certain things that I can do before I cross the security. So at max, I can probably drop my baggage. At max, I can sit somewhere. but I might not be able to access the lounge because that access is not given to me after I do
ನಿಮ್ಮ
the
ಮನೆಯಲ್ಲಿ
Dishiyatra
ಪೈಪ್
check and
ಹೊಡೆದಿದೆಯೇ
get into
ಅಥವಾ
the airport.
ಬಿರುಕು ಬಿಟ್ಟು ಸೋರಿಕೆಯನ್ನು ಉಂಟು ಮಾಡಿದೆಯೇ?
And every time you are pulled aside by the security,
ಆ
like last
ಭಾಗವನ್ನು
time,
ಕತ್ತರಿಸಿ ತೆಳುವಾದ
last
ಪೈಪ್
evening when they
ತೆಗೆದುಕೊಳ್ಳಿ,
pulled out my
ಟೇಪ್
bag and
ಸುತ್ತಿ
told you have a lot
ನೀರಿನ
of
ಹರಿವನ್ನು
wires and
ಇನ್ನೊಂದು
power
ಕಡೆಗೆ
bank and show
ತಿರುಗಿಸಿ
us what all you
ಅಂಟು
have,
ಮತ್ತು ವಾಲ್ ನೊಂದಿಗೆ
they'll
ಬನ್ನಿ.
tell you
ಆ ಕೆಳಗೆ
exactly why you are stopped. So if you see, you put your tape, the basket, they'll put it at this place, they'll scan it, and they'll show you exact image with the circle that's stopped. So they'll tell you exactly why they are stopped. They'll never stop you for no nonsense reason. If there is something wrong, that's when you are stopped. So there are 4 very high level, very precise checks on who I am, what I am allowed to do, why I was stopped, just for one can of ginger ale. So imagine doing so many things for ginger ale. How many checks do we have for our AI agents? A lot of us at companies, we have platforms that we are using. A lot of enterprises and teams are incorporating AI agents. You have AI agents everywhere. It could be accessing your docs and giving you solutions. It could be an SRE agent. It could be an observability agent. So as a developer, you just go ahead, click something, and then it just does something for you, and whatever the problem is, it solves. But then why don't we have so many checkpoints for such AI agents? So look at your current platform that you have in place. AI agents are coming to all of your platforms. How many of you use some sort of a platform within your teams or companies? It could be something as simple as a Kubernetes, or it could be something like a Zeus Rancher or something of that sort. So yeah, quite a few. So I'm sure you would be seeing some sort of an integration of AI within that. A small bubble coming up from somewhere that, hey, try this out. Hey, try that out. So that's how the adoption happens. So it's already present in SRE space. I'm sure you would have seen a lot of talks today itself speaking about SREs, about AI ops, cost ops, FinOps, a lot of areas where your AI agents are already in. And incident response is obviously, one of them where it is being used heavily because, who is going to sit and gather logs from your 10 different systems that you have. That's where we use AI that, get me logs from all the systems, tell me what's wrong, correlate it and tell me what's wrong with the entire system. Now what's happening is the adoption is actually increasing at a very fast pace. So initially when it was just going to tell me what my docs are, now it is able to perform action using, let's say, MCP servers. Now it's able to go and perform actions as well. So it is also progressing over time. But the problem is the governance that was set for your platform is not advancing at the pace at which your AI agents are evolving. And this entire space is not hypothetical at all. I'm not making up stories over here, and I have proof to back on whatever I'm saying. So Google shipped Agent Sandbox on Kubernetes last year. Anyone aware of that news? Yeah. So Agent Sandbox, because you know that your agents are now running in production, you needed a safe environment for them. You needed a protected environment where agents can run, where there are guardrails for them, where there is governance for all the AI agents. So that's what Google shipped last year. OWASP came up with the Agentic AI top 10. How many of you all know about OWASP? Wow, love it. So OWASP is, every year they come up with list of threats. Back in the day, it was OWASP Web 10. When I started my career, it was about Web 10 of top 10 web threats. Then obviously there was an LLM top 10. And then last year again, there came in the Agentic AI top 10 because obviously AI agents are taking up a lot of things that we are doing, and that's where threats are also increasing. And then we also had the EU Act coming in, which came in August 25. And one of the articles specifically says that all the AI decisions that are being taken by your system needs to be traceable, challengeable, and reversible. So this is a clause within the EU regulation that came in. You can go and check it. It's Article 13 as per my notes. So you can go and check it. So at a governance and a policy level, these are the changes that have happened. Even our own India, MITI also came up with their AI guidelines in November last year. And they have actually called out 3 words that I would be repeating a lot in today's session: accountability, understandable by design. So these are the 2 things that are clearly mentioned in the AI guidelines that are given by MITI, which again answers the question of who, what, and why. These are the things that your AI systems must be able to answer. So, and then lastly, you had CNCF launched the Kubernetes AI Conformance Program. So this happened at KubeCon Atlanta, that was there in December. And this again is going to focus more on the Agentic AI and certification category. And if you see, all the news over here is actually pointing to what is actually happening right now. Everything, we started the year with a lot of buzz around MCPs and AI agents and stuff. But by the end of 2025, all of the things are converging. So you have the foundation coming up with a specific dedicated program for agentic AI security. You have OAFs listing down threats that are associated to AI agents. You have countries and governments coming up with policies that are adhering to AI agents. So none of this is actually hypothetical. So how many of you think I used AI to write this slide? Okay, whoever agrees, 100 marks to you. 3 a.m. I mean, I have never been on production and only AI tells that everything happens at 2 a.m. or 3 a.m. Whether it is Claude or ChatGPT, if you ask it to generate a scenario for you, it is always 3 a.m. We probably need to sit and figure out what happens at 3 a.m. actually. So anyway, so it's 3 a.m., something goes wrong, production scales to 0. And then your on-call page is gone and your on-call engineer opens the audit log and sees system service account AI ops. That's the only thing that's present in the logs. And investigation has to start from scratch because the on-call engineer has absolutely no idea that who this service account is, what timestamp, maybe, action what he has taken, why this action was taken, why it was scaled to 0. Absolutely no idea. They didn't know where this agent was triggered from, whether it was triggered by a button click, whether it was invoked by some script, whether it was invoked due to some scheduled job. Absolutely no idea of what that has happened. Was there a policy that could have prevented this? I have no idea. Was this something that someone could have done? I have no idea. So you see, even though we had an AI agent in place, who was actually there to take care of stuff and ensure nothing goes wrong, it actually goofed up and none of the one in the team had absolutely any idea of why this particular thing happened. So your platform was initially built for humans, the human operator. Now we have an AI which is a newer operator that has come to the platform. So when humans act, there is always an audit entry in the log. Atul, increase the replica set to something, you will see the entry with my username. Ram deleted a cluster, you will see the entry in the audit logs. So every action with a human is attributed in the audit logs. RBAC controls what they can do. Am I an admin? Yes. Can I delete a cluster? Yes. Am I a developer? Yes. Can I delete a cluster? No. So that's how RBAC works. Audit trails will give me the complete picture of what happened. If I was a developer, I'm requesting to delete a cluster, it says no. So all these things are tracked and we know exactly who was trying to access, what they were trying to do and why they were denied or why they were allowed to do something. But when AI agents came in, the easiest thing that we did was we created a service account, broad access, read, write, execute, everything. We did that, created a token, gave it to our AI agent. Now your AI agent is like, aaj mere ko delete karna hai sab. He'll get away and he'll start deleting and you have absolutely no idea again as to why it did so. So you're using the same set of tools, you're having the same set of policies, everything remains the same, just your operator has changed. Previously it was a human operator, now you have an AI operator and your problems have gone 10x. So what are the 3 challenges that we are going to look into? Again, I'll get back to the airport analogy. We need to understand who triggered this agent action. We need to understand what boundaries were applied to the action that the agent took and why did it make this decision. Until unless you have answers to these 3 things, you will never really understand why your agent took a particular action, who triggered it, and whatever happened, why did it happen. So every time an incident happens, these are the same questions that you need to ask. And if your system or environment or infra is able to answer these questions, it means you are on the right track to getting things implemented. So who triggered this action? Audit log currently shows the service account. There is no human associated with it. Was it created by Alice? Was it created by Ram? Was it created by Atul? Was it in a Slack and I just clicked the button, fix it, and the agent was triggered? Was it done by an automated script? I have no idea. I have no name, no team, no context. No idea who triggered it. What boundaries should have been applied? So RBAC, like I said, it knows, yes, I have role, I have access. Can I do it? Yes. Have I role? Do I have access? No. Can I do it? No. But then RBAC doesn't know if Atul's team has access to increase replica between 2 to 5. It just knows, can I increase replicas? Yes. But can it do between 2 to 5? RBAC cannot answer it. You need some policies to attach to it. And the same thing is needed with AI agents as well. And lastly, when all of this happens, agent observed something, it acted on it. What did it see? What was the reasoning behind it? What is the decision that it took? We all look like those cows over there. Absolutely clueless. It has done something, something went wrong, something happened. You have a war room, 15 people, 15 cows sitting. looking at each other, boss, AI ने कुछ तो कर दिया. It's a complete black box. And that is why you need more accountability, as and when you are adding more and more AI agents. So the question is, how do we fix this? And the answer to this lies in platforms. Not that I am the organizer of a platform community and I talk platforms, but genuinely the answer lies in platforms. And why do I say so? So how many of you all know why platforms came into the picture first place? Just raise of hands, I'm not going to ask a question. Few people. So DevOps, you all know a lot of teams, let's say, for example, your boss comes and says, we have to implement automated pipelines. You have 5 different teams. One team chooses CircleCI, other team uses Jenkins, other team uses GitHub Actions, other team uses Azure pipelines. So at a higher level, yes, 100% coverage of automated CI/CD pipelines. But when you actually see it, every team has their own tool implemented. And that's a problem. Because when something goes wrong in CircleCI, you have no clue what's happening in Jenkins. So you again have to go and take logs from 5 different systems and figure out what's happening. Each of these tools has its own configuration. So to get rid of this problem, platforms were created because they give you standardization. Every team in the company will use the exact same script, exact same configuration for the exact same thing that you are doing. Even framework level, you cannot fix this particular problem. Because let's say if I'm using a particular framework like a LangChain or a AutoGen or whatever, right, at whatever orchestration layer that I'm using as a team, I have the choices that I have to make. And I can make something which suits my team. I don't want to log who did this action. The other team will be like, I don't want to log what action was taken. So again, different teams, they have implemented it, but they are doing it in a different way. And that is why you need to standardize every implementation that happens. So platform becomes that single point of enforcement. One place which is consistent, non-negotiable. So anything that your teams do from the platform will be standardized and consistent. Not like 5 teams using 5 different scripts, 5 different tools to get same thing done. 5 teams, 1 tool, 1 script to do everything. And then what that will do is, because we'll have guardrails and accountability in place, which I'll get to next, that will always be consistent with everything. So I'll touch upon 3 patterns, which will touch upon again the same questions, who, what, and why. So the first one is user context propagation. We need to understand who actually triggered that particular agent. You might have an autonomous AI agent to do a bunch of things, but then it triggers at a particular time, or someone actually triggers it. So it should be, so it could be like, let's say something went wrong, and in my Slack, I got a notification that something has gone wrong, and I just give /bot increase replica set, enter. I send this command, the replica set increases because agent got the command, it did it. Another side, maybe I'm running a cron job, which runs at every day 12 AM, and that triggers a particular agent. So now who created this cron job? Was it done by the DevOps team? If I am doing it from Slack, who triggered that agent? It was me who actually triggered that agent. So propagate the human identity with every action that the agent is taking. So when I click a button on Slack, say fix it, with the entire request that goes to my cluster or whichever system it's going, just add an annotation extra which says who triggered it. So it would be me. Atul clicked on the fix it button, and that is what triggered the AI agent to do whatever it did. So in the Kubernetes world, we can use admission webhooks. Kyverno is a popular policy engine that can do all of these things. So you set a policy. We'll see the code in some time. You set a policy which says that any request that is coming into my system, if it doesn't have a user label attached, reject the request. So that is where your standardization will come into picture. So any request which will be raised by anyone in the team using the AI agent, if it doesn't have a user context, it will be rejected. So now you're adding some form of traceability in your requests that are coming in. Pattern 2 is dynamic permission boundaries. So I spoke about RBAC. RBAC can tell me yes or no whether the person has access to do a particular action or not. But does it have context-aware rules? RBAC doesn't. So again here, you create policies. So when you move from the first stage to this one, at this point, you have a policy which says Ram's team can increase the replica set to 5. Atul's team can increase replica set to 10. The kind of images that they can use is only from this particular registry. These are the kind of instances that they can use. So these are the dynamic policies that I will create. So the moment the agent is triggered, and if agent feels that I need to increase the replica set, I will have this policy right next to it. So this policy will check, okay, AI has said I need to increase the replica set to 20. But as per this policy, it cannot be more than 5. The request will be blocked over there. So you know that whatever action the AI agent will take will be within the boundaries of what guardrails that you have set. So this is the second level where you are going to fix things. And if something goes wrong, send a clear rejection message back to the user, back to the AI, without, just give them the entire context that why a request was rejected particularly. And last, the most important one is decision attribution. So we all know that once we have an AI system in place, you have given it the data, you know what has gone wrong. It will send it to LLM, your LLM will probably reason it, and then come back and say that, hey, we need to increase this, we need to delete this, we need to configure this, we need to patch this. It will come with all of it. It's important to capture the entire reasoning change so that you exactly understand what was sent to the AI agent, what it understood, what was its reasoning, and why it took a particular action for it. So instrument agents with simple tools like OpenTelemetry. I'm assuming everyone here, or most of you know OpenTelemetry here. Yeah, sure. So OpenTelemetry you can use to instrument all the agent calls that are happening. So all the metrics that is being taken at that particular point in time. It could be your CPU metrics, it could be your health metrics, it could be your application metrics. Take all of this, send it to the LLM along with all the request code, get the reasoning as well, and then capture the action as well. So with every action that is happening, you have a trace ID in place, and your trace will actually capture all of these details based on what the LLM has taken. So every decision that your system will take now, you will have a complete record of it. You will have a complete reset of it. So if I have to, give the full picture again, I am using my platform. It said that something has gone wrong. My AI pops up from here and says, this has gone wrong. Do you want to fix it? I click yes on it. The moment I click yes on it, internally the request goes that Atul has clicked yes to trigger this agent to fix this. That request will go to the system. The moment it hits the Kubernetes cluster just before that, my Kyverno policies will check whether I as a user and the agent have access to do a particular action or not. If yes, that request will flow to the AI, the LLM that I'm using, and this entire thing will go to the LLM, get back with all the reasoning that it has, and all of it will be recorded in my observability tool that I'm using. So we would use Hotel for instrumentation. We can use Jaeger for displaying what's happening. I'll go on to the demo. Apparently the demo isn't working. It's not supposed to work, right, on the final day. I had a video because I'm experienced now. I give a lot of talks, so I know demos don't work on the final day. Actually, I was having lunch and lunch was good. I came to my laptop and I was like, let me fix the demo. And you know what I did? Teardown.sh. That's the first script that I ran. And the entire demo was gone. And I'm like, I don't have time to set it up again. So this is my GitHub repo. You can see the code is there. It's a very simple implementation. Again, used AI to generate this demo as well. But I told what I want. So this generated to that. So what this will basically do is we'll see a few actions that, with and without policies. And we'll also show you the last, the OpenTelemetry bit that I was mentioning about attributing all the actions to a particular user and the request not being, moving ahead. So if I go here, right, so this is the setup script. Oh, wait, sorry. See, AI cannot do this. Sure, so this is the setup script. So it basically, the GitHub repo that you see, it will set up the bunch of things that's needed over here. So it has a before and after. So the before one doesn't have any policies or anything in place. So if you ask it to increase replicas to 100, it's just going to do it. It's a simulation over here. You can obviously replace it with your AI endpoint that you need. This is just the script that actually does the actual work that it's supposed to do. So there is a simple deployment that's Nginx is what we are trying to deploy over here. Now, once this setup is actually ready, what it'll do is, so let's go to first part. Right, so here if I say, just go ahead and create a deployment, it's going to create it. The number, whatever I give, if I give 4, if I give 10, if I give 50, is just going to do that because there is no policies set over here. Now the second one, I'm going to ask, the user is actually triggering to say that you increase a particular replica set, and the agent comes back and says that, okay, these are the things that we can do, and this is my standard record that is there in the audit log. So if you go to audit log, it will just tell me what are the resources, what is the namespace, what are the things that it has captured. So this is the only thing that is currently captured. So if you see, there is no user context over here. So agent did something, but what it did was only this, and there is no attribution over here. So the next step what we'll do is, now that was the before part. In the next one, we are adding Kyverno policies like I mentioned, which are going to ensure that the user propagation actually was over here. So if you see here, I said that every request should have a user context mentioned. So if you remember when I spoke about me clicking on Slack, the fix button and Atul goes with it, this is the Kyverno policy for it. So it says that if the request doesn't have this particular user annotation in the request, the server is going to reject it, which means it's not going to go ahead and do anything. And that's the Kyverno policy that is actually doing it. Again, you can check that in the Git repo. And then similarly, this is the dynamic one. So here it says the replica count. So based on what the LLM comes back with, I have a policy here which tells me that this team is allowed only to extend the replicas to a certain point. So here it's asking the AI to scale to 10 replicas, but she has access only to 5. And this is what the policy will fail the request. And if you see, the request is blocked. And this is and these all actions are happening by the AI agent. So AI is coming back and telling me that this needs to be done, and it doesn't have that access. So this is Jaeger tracing tool. So we have implemented all the traces over here. So if you see here, the agent was triggered by Alice. So that's the user context that I have. And then what are the action that it was trying to do? And this was the policy that blocked it. That the agent was trying to increase the replicas. It was triggered by Alice. And this is why it was blocked for a particular reason. Similarly, last one here is the LLM context over here. So capturing the entire range. So this is the model that is actually getting me the response. That is the reasoning, which it says the LLM reasoning, what it understood of, why this things need to be done. So it says CPU utilization and the raw response, and then it actually goes ahead and completes. So now if you see, we have implemented the entire who, what, and why, and made this entire system more accountable. Because now when your LLM goes and deletes all the replicas, you know exactly who triggered it, you know exactly what boundaries were set, and you exactly know what the entire reasoning and decision chain was to arrive at this particular situation. So that's the demo, and let's get back. Right, so what we saw over here was basically RBAC. RBAC can just control the access, but it cannot control the accountability. And that's what we try to add with the demo that we have created over here. So every agent action that is being taken, attributing it to a user context with a human identity, we created policies that checks things that traditional RBAC cannot do. And then we use OTel to trace the reasoning and not just the action. So eventually what I'm trying to say here is that the whole accountability bit needs to be driven by the platform, because that's the centralmost place from where you can govern all of these things. So what's next after this? The OTel GenAI semantic convention is now GA. So what you saw over here, the Jaeger part where the LLM reasoning was there, it was in the demo, it was instrumented manually. So all that code was written manually, but the latest version of OTel actually comes with semantic conventions. So you can directly use the internal semantics to get the details from your LLM, what model, what reasoning, what was the chain of thought. You can do that already. CNCF AI conformance accountability as certification is already live. A lot of things are happening in the AI conformance group as well in the CNCF, so you can check that out. MCP and agentic AI, agentic identity is another area that's gathering a lot of interest. MCP, obviously, I know a lot of people here would be using it. But agent identity is another big space where a lot of work is being happening. So if you are interested in security in AI, that's the space to watch out for. The good thing is that the policymakers are also moving in the right direction. They've realized what AI can do. And that is why a lot of policies are coming in by the countries, and compliance will need to ensure that they adhere to all of this. And then eventually, you will have platform teams that will own the entire AI governance for your complete organization, because that's the single place where the entire implementation can happen. So yeah, that's my time. That's the blog post that I wrote about this, and obviously a lot more things added to it, so you can just scan and read that. That's a little extension of this particular talk, which focuses more on, again, agentic AI and security as well. And yeah, that's my time. Thank you so much.